Hello everyone. So today we are going to solve this question. So this is to find if the given tree is symmetric or not. So for example, in this first case, the root is 1 and the left and right child of this root is 2, which is same, and for this left one the left child is 3 and for the right one the right is 3. So this is also symmetric, and for the right child of the left root, that is 4, and in the right side also the left child of 2 is 4, so this is also symmetric. So in this, what we can do is we can check if the root is null, then we can return simply true because that is the base case, and if it is not null we will return if. We can create a helper function that will check if the child of that node is same or not, is symmetric or not. So we will check if the mirror of root dot left and root dot right. Now we will create the helper function. So this will return a boolean value, and the arguments will be two nodes of the tree, so we can call them as t1 and t2. So in this, what we can do is we can check if both of them are null. So if both of them are null, then this means that they are symmetric. So we will return true, that they are symmetric. And if both of them are not null but one of them is null, this means that if t2 is equal to null, or if t1 is equal to null or t2 is equal to null, this means that only one of them is null and the other is not null. So we will return false. Now if both of these conditions are not true, this means that both of them are not null and they are having some values. So we will check if the values are same or not. So we will check if t1 dot val. So if they are not equal, we will return false. So if t1 dot val is not equal to t2 dot val, we will return false. And in the last case, we will return if the child of those nodes are symmetric or not. So for this one, we will check t1 dot left with t2 dot right, and t1 dot right with t2 dot left. So for example, in this case, the t1 dot left, if t1 is 2 and t2 is this 2, so t1 dot left will be 3 and t2 dot right will be 3. And for t1 dot right and t2 dot left, so both of them will be 4, so this will give true. So now we can run this code. And submit this one. Okay, so now this is submitted. So now for the time and space complexity, the time complexity of this one will be big O of n, and the space will be the equal to the depth of this recursive calls, and here n is the number of nodes in the tree, and depth will be the depth of recursive calls. And in each recursive call we are taking constant space, so this is depth into 1. So this 1 is for all the recursive calls, so which is equal to the depth. So this is the solution for this one. Thank you for watching the video, and do like, comment, share and subscribe the channel if you like the video. Thank you. And you can find the code in the description below. So you can check that also. Thank you.